Hello students, this is our second class on quick revision series of electrostatics. Today also we are going to solve few more interesting problems on Coulomb's law, potential and capacitors. So I am D.N.Thatoi. Welcome you all to my new YouTube channel Physics Sketch. Let us start with this problem given on the board. So now the figure shows two metallic spherical cells. There are the two metallic spherical cells. So the radius of the inner cell is A, radius of the outer cell is 4A, and charge given to the sphere is equal to 20 microcoulomb. So that is the given cells, and both these cells are metallic cells. They are the metallic cells both, and they are isolated. So initially charge was given to 20 microcoulomb. Now the question is find out the charges on the surface 1, surface 2, surface 3 and surface 4. This is your first question. So now, when the charges are given to the sphere, outer sphere, so you know no charge will be present inside, no induction inside according to the Gauss law or the concept of lines of force that already we have discussed in our previous video. So you can refer that one. So now the entire 20 coulomb will be present on the outer surface. The charge at the surface 1 is 0 before, charge at 2 is also 0, charge at 3 also 0, and charge on the 4 is entirely 20 coulomb. That is the first case before the case. Now initially given, so these are the charges distribution: surface 1, 2, 3, 4. So 1 is the inner surface of the inner sphere, 2 is the outer surface of the inner sphere, 3 is the inner surface of the outer sphere, and 4 is the outer surface of the outer sphere. So this is all about the charges. Now the question is, so the inner sphere is earth. So if the inner sphere will be earth, my question is what will be charges on the inner and all the surfaces 1, 2, 3, 4. This is a very interesting problem. So frequently asked in the different examinations. So that's why let us solve. So when if the inner sphere will be earth, let the charge appears on the outer surface of the sphere is equal to Q. If the charge is appear Q, then question is what is the concept to solve the problem? The concept is if any body is earth, potential is equal to 0. So that I can cite the potential of the surface inner sphere is equal to 0. This is the inner sphere, this is the outer sphere. Potential of the inner sphere is 0. Then what is the charge on the inner sphere? Let Q. Then it is equal to Q by A, because radius of the whole sphere is A, charge is Q, potential is Q by A. Again, what is the potential of the inner sphere due to the outer charge? The potential of the inner sphere due to outer charge is Q, and charge is 20 microcoulomb. Radius of the outer sphere is 4A is equal to 0. So you know potential of a point is due to the charge on its own sphere, and potential of this point is due to the outer sphere because this point is inside the sphere. From the principle of superposition of potential, net potential is the algebraic sum of the net. So then they show that K by A common, so then Q is equal to minus 20 by 4, that is equal to minus 5 microcoulomb. Yes, so I got Q is equal to minus 4, that is equal to minus 4 microcoulomb. Sorry, minus 5 microcoulomb. So Q is equal to minus 5 microcoulomb. Then what is the answer? Now come to the answer. Again the net charge on the inner surface will be 0, that you know. So charges are not always, all the charges are on the outer surface, no charges will be present here. The charge on the surface before is 0, now after is also 0. Now charge on the surface 2, this charge on the surface 2 is equal to minus 5 coulomb, that is equal to minus 5 coulomb. And since this charge is equal to minus 5, so here it will be induced plus 5. Total charge is 20, so it will remaining is equal to 15. So 15 plus 5 is 20. So the charge on the surface 3 is equal to plus 5. Charge on the surface 4 is equal to 15. So this is equal to charge on 3 is equal to plus 5. Charge on the surface 4 is equal to now 15. So this is the charges before earthing and after earthing. This is a very important problem. Now come to next problem. Please note down. So the main important concept is potential of a sphere connected to the earth is 0. That is the earthing. So now you may refer the previous video. I have explained nicely. So what are the potential and how the charges will be redistributed when it will be earth. That part is over. Now come to the second problem. The second problem is again important problem, very interesting problem. There are three metallic spheres. This is sphere A, this is sphere B, and this is sphere C. There are they all are. This is the sphere A, this is sphere B, this is sphere C. All are metallic spheres. All are metallic spheres. All are metallic spheres and all are identical. Radius is R, radius is R, radius is R. And all are uncharged. Initially all are uncharged, no charge. All are uncharged. So another identical sphere, it is also metal, same radius, it is also metallic. It is also metallic. Charge on this, name of this sphere is B and charge is given, say, that is equal to 24 microcoulomb. Let's say charge of this sphere is 24 microcoulomb. This is uncharged, 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 A, B, C. Then I have to find out this sphere P is connected, kept in contact with A, then removed. Then again this kept in contact with B, removed. Again kept in contact with C, removed. Then finally, what will be the charge on this sphere B and what is the charge on this sphere C, B, A? This is our question. So very interesting problem. So now what is the principle of solution? The principle of solution is when two bodies will be kept in contact, their potential will be same. So accordingly they will share the charges. Since all the spheres are of same size, so they will share equally. Because the capacity of this sphere, capacity of this sphere, capacity of sphere, all are same. Because the radius is same. Capacity depends upon the radius. So this capacity is also same. Since all are same, they will share the charges equally. If they share the charges equally, then what will happen? Now first P will be kept in contact with this. So when P will be kept in contact with this, what will happen? Now they will share the charges equally. Then how much charge will be here? Now charge will be here 12 and it will be charged 12. The total is 24. The total 24 will be cancelled. So it will be shared 12. Now this sphere is come to here. Now it will be coming to B. So now when it will be here, then now initially it will charge 12. Then when it will be coming in contact, the out of the total 12, so here it will be 6. Then again it will be 6. Then the sphere is kept from this point. Again this sphere. Then sphere is kept in contact here. Then again they will be divided the charges. So initially how much? 6. Now it is removed from this and kept in contact. Then it will be 3 and this will be 3. Then what is the final answer? The final answer is this sphere P. So now is replaced from this position. Then finally sphere P is equal to here. How much charge? 3 microcoulomb. So what is the charge on C? 3 microcoulomb. And 6 microcoulomb, 12 microcoulomb. Then let us show in a tabular manner how the charges are distributed. So the tabular manner you can show like this. Let's say this is equal to A, this is equal to B, this is equal to C. Now this is the P. Now this is the final charges of A, B, C. This is the final. This is the final. And the initial charge of A is how much? Initial charge of A is equal to, then you can say initial charge here, this is the P. Initial of charge A is equal to 24 microcoulomb was given. So when 24 microcoulomb will be P will be kept in contact with A, what will happen? Now A will keep charge 12. Then P itself will keep charge 12 microcoulomb. Again, when P 12 coulomb will be kept in contact with B, so it will be divided, it will be 6 microcoulomb. Then P itself will keep 6 microcoulomb. Then when it will be kept in contact with the C, so it will again keep 3 microcoulomb. And P will be finally will keep 3 microcoulomb. So now the final charge of P will be 3 microcoulomb, and C will be 3, B will be 6, and A will be 12. So they all total coming to be how much? 21. Summation is equal to 21 microcoulomb. This is 3 microcoulomb. Total charge was given 24 microcoulomb. Because all these pure sets same size, that's why the solution becomes easier, and this is the analysis. If the radius will be different, then according to their capacity they will share the charges, but main concept is potential will be same, they will share the charges. This is question number 2. Now come to question number 3. Please remember all the metallic spheres and radius are same. That's why it is happening like this. Now come to question number 3. So they are very interesting problems. Now all the time I will be coming with the, so now there will be 5 number of series problems. So quick revision series, 5 number of series. This is series number 2. Then more 3, and all the interesting problems on electrostatics I will be solving. And definitely you will enjoy the class and try to remember and practice. The question number 3 is, there are 2 capacitors given. So this is a capacitor. The capacitor is C1. This capacitor is C2. This potential is V1. This potential is V2. Let us find out the potential. Let's say the point is B, this point is A, this point C. I have to find out potential of the point B is how much. Let X, that value I have to find out. That is your question. So again I am repeating. 2 capacitors C1, C2, they are connected in one line. Left hand point is V1 potential, rightmost potential is V2. I want to find out the potential of the point B in steady state. So to solve the problem in steady state, then I have to assume let so V1 is greater than V of the point B, and V of the point is greater than point that is the C, that is equal to V2. That means V1 is greater than X, because potential of the point B is X, and that is equal to potential of the point is equal to V2. So let's say again you know that since this potential is more than this, then charge will flow how much? Q. So according to principle of conservation of charge, same charge will also move from B to C, same charge, because this is a single line. In a single line, charge cannot be different. The amount of charge flowing from A to B is same as the amount of charge coming from B to C. The charge remains the same. Then what is the formula of charge? You know in a capacitor, Q is equal to C into potential difference. So Q into C into V. V means potential difference. So how much charge will flow this to this? Now the charge from Q from A to B is same as Q from B to C. So Q from B to C formula is C. What is C? C1. What is delta V? Now V1 minus X, that is equal to V1 minus X. Then how much charge will from B to C? That is equal to capacitance is C2, and potential is X minus V2. That you know, this is X, this potential is V2, X minus V2. Then I can write that is equal to C1 V1, then plus C2 V2, just changing the sides, is equal to C1 X plus C2 X, then taking common X. So the potential of the junction is equal to C1 V1 plus C2 V2 divided by C1 plus C2. This is the potential of the junction in steady state. So irrespective of the capacitance, irrespective of the potential, so you apply this formula. Then you write which potential is how much, which charge is how much. Accordingly, you may put to get a particular problem. Now come to question number 3. Again, this is more interesting. So now in addition to that, another problem solving. Look here. The problem, the same similar pattern of problem that I am solving here. The third question, the fourth question is there are three capacitors. So now this is a capacitor, this is another capacitor. So this is again a very interesting problem. So all questions are asked in the exam very frequently. Frequently they are asked. So let's say the potential of this point. Let's say the potential of the point is equal to 40 volt. This is equal to 40 volt, and this is equal to, let's say, this is equal to 20 volt, and this is equal to say 10 volt. Let three terminals are given. The potential 40, 20, and 10. The capacitance of the capacitor is equal to 2 microfarad. This is equal to 3 microfarad, and this is equal to 1 microfarad. And I have to find out potential of this point is equal to how much. That is a question. Same method, same pattern. So what is the potential of this junction? Very important problem. Maximum time it is asked in the examination. Frequently in different examination it is coming. So now the question is, let's say this point is A, this point is B, this point is C, let's say this point is O. Then the charge going in this line, let's say it is Q1. The charge going along this line, then let's say it is Q2, this is Q1, and charge going along this direction is equal to Q3. So according to principle of conservation of charge, because when you are solving a problem in physics, all the time you are converting the numericals, converting the data into a equation, and equations are always based on a principle or based on a law. So that the law is principle of conservation of charge at a junction. So net charge coming to a junction is equal to net charge going out of that junction. So this shows that how much charge is going to junction O, Q1 and Q2. Then you write that is Q1 plus Q2, and that combined it will flow as Q3. So the amount of charge reaching the point O is Q1 and Q2, and it will go as Q3. So now what is Q1? Again you know the formula. Q is equal to CV. V means potential difference. Then come to the first line, the Q1. The capacitance is 2. The capacitance is 2 because you know Q is equal to CV. I am putting formula. Q is equal to CV. C is equal to 2. V is equal to 40 minus X. So that is 2 into 40 minus X. Then how much charge will flow along this line? That is equal to capacitance is 3. Q is equal to CV, C is equal to 3, V is equal to 20 minus X, that is equal to 20 minus X, and Q3 is equal to capacitance is 1, C into potential difference is equal to X minus 10. Now let us solve this problem. It is coming to be 80 minus 2X plus 60 minus 3X is equal to X minus 10. Now solve this. 80 plus 60, that is 80 plus 60 plus 10 is equal to 2x plus 3x, 5x plus x. It is equal to 6x. Then I am getting that is equal to 8 plus 6, 150. That is equal to 150. Look, so 8 plus 6 plus 1, 150. It is equal to 6x. So then I am getting x is equal to 150 by 6, 25 volt. So the potential of the junction O is found to be 25 volt. It is 40 volt, it is 20 volt, it is 25 volt, it is 10 volt. This is how the problem is solved based on the Kirchhoff's law. So now another problem we are going to solve, and that will be based on the Coulomb's law and the time period of a simple pendulum. Okay. The next problem is like this. The next problem is there is a simple pendulum. Mass of the pendulum is m, charge of the pendulum is E, and the length of the pendulum is this, and acceleration due to gravity is equal to g. Then you know the time period of a simple pendulum, you know already, that is equal to 2 pi L by G effective. That is the formula of a time period of a simple pendulum. In 12 first year, in 11th class already you have read. Time period of a simple pendulum is 2 pi L by G effective. Effective G, net acceleration. So effective G. So here, if electric field is applied downward, and this body has charge Q, how much force will be acting? The force is equal to mg is the gravity force. Again, electric force is equal to E into Q. That is equal to, you know, electric field is equal to F by Q. That is the definition. Then what is force? Now force is equal to EQ. So now force is equal to EQ. What is the net force? The net force is equal to net force is equal to mg plus EQ. This is the net force. Net force is equal to mass into G effective acceleration. Effective G is equal to mg plus EQ. Then the G effective is equal to mg plus EQ divided by m. So it is equal to G plus EQ divided by m. Now the time period in the problem will be, if the electric field is downward, then the time period will be how much? Now the time period is equal to T is equal to 2 pi L by G plus EQ by m root over. This is the time period of a simple pendulum if the electric field is downward. So now this is the result. So how I have calculated? Again I am repeating. The time period of a simple pendulum that is oscillating depends on what is the net effective acceleration due to gravity. What is the net effective acceleration? How to get the effective G? So time period 2 pi L by G effective. How to get the effective G? Effective G depends upon the net force acting on the body. So how much force is acting on it? Gravity, mg. Since electric field downward, that is EQ. So net force is equal to this. Again, you know from the Newton's law, F is equal to mass into acceleration due to gravity effective. This much. Then you are getting effective acceleration. Then put in the formula. That is the time period of a simple pendulum where the E is downward. Second case, if E will be upward. So if E will be upward, then this force will be upward. It will minus because gravity is downward. Electric field force will be upward. Net force, then it will be minus. Then it will be minus. Then the time period will be minus. Accordingly, you will say the time period may be increased, time period may decrease. The pendulum will be go fast or it will swing slow. That depends upon the electric field acting on the body. So another part is, last part is if. So another part is if in this case simple pendulum case. Now this is the simple pendulum. So now instead of vertical, let's say electric field is horizontal. If the electric field is horizontal on the body, one force will be mg, another force will be EQ. So obviously the pendulum will be shifted like this. So now what is the net force? Net force is equal to how much? Net force is equal to in the body two forces are acting. One force is EQ, another force is equal to mg. So the net force is equal to this much. So that is the net force. Then I can write F net is equal to mg square plus EQ square root over. And the net force is equal to mass into G effective is equal to this much. After getting the G effective, then I can get G effective is equal to, I am writing here. So G acceleration due to gravity effective G is equal to divided by mass. It is equal to G square because m cancel G square plus EQ by m square root over. This is the net G. Now after putting this value, now the time period of the simple pendulum in a horizontal electric field will be how much? Now the time period of a simple pendulum in a horizontal electric field is equal to T is equal to 2 pi root over of L by G effective. G effective is equal to G square plus E cube by m square root over. This is the time period of a simple pendulum. So this is all about your class today. I hope this time also you have enjoyed the class. Keep watching. I will be back with more number of interesting problems on Gauss law and many more. Thank you.